Okay, time for another video. This time I am going to be installing a Shelly 2.5 behind this light switch here in the hallway of my house. I wanted to do this for a few reasons. The first is, or the main reason is that the Shelly will be controlling the spotlights up here, and the spotlights are actually controlled by some Hue the motion sensors. And that works really well. So when somebody walks into the hallway, the motion is detected, the lights turn on, and I use Home Assistant to then control what type of light comes on at different times of the day. So in the day, in the middle of the day when it's dark, it will come on bright. In the early evening, it will come on with a warmer light, and overnight it will come on as like a night light, just enough light to be able to walk around. But of course, I face the common smart home problem in that when a relative or somebody who's not familiar with the house comes around, they try to turn off the lights or turn on the lights using the switch. And when they do that, it kills the power to the lights completely, and then they don't work. So what I'm wanting to do is install the Shelly behind this switch so that when somebody does flick the switch, it turns the lights on. It doesn't actually disconnect the power, but it just tells the lights to come on. And more importantly, when they flick the switch again to turn everything off, it doesn't disconnect the power from the lights, it just tells them to turn off. And then after a set amount of time, after that, the switch has been used, the motion sensors will take over again. So that if the motion sensors detect movement, it will turn them on, or if somebody flicks the switch on, it will override the motion sensors and always turn the lights on. My thought there is that, like at night, as an example, when the motion sensors turn the lights on to a night light, just enough light to be able to move around, but if you need the lights on properly, you can flick the switch, and then it would override that logic and turn them on so that they're bright and you can see what you're doing. So that's kind of the main aim. The second aim is, you might not be able to see this, but let me see if I can move the camera. There you go. But this switch actually has, this light switch here actually has 4 independent switches. And this one on the very left doesn't appear to do anything. So I don't think there's anything connected to that. So if there is not, I'm going to connect this switch to the second relay or the second switch on the Shelly, and then use that as a virtual switch to control something else. So maybe that would control the Govee lights outside that I installed a little while ago. I'll include a link of how I did that above here. Or maybe I set it up so that when that when that switch is used, it turns off all the smart lights in the house, so that we can use it as a way to know that when we're leaving the house, everything's definitely off. I'm not quite sure how I'm going to use it yet, but one of these ideas will turn out to be useful, I'm sure. So yeah, let's get on with it. Before I get on with it though, I do want to just say that I am not a qualified electrician, so please do not use this video as instructions on how to do this in your house. Every house is different, every country has different electrical standards, and even in the same country, houses built at different times can be completely different. So everything that you see in this video is just going to be about how I managed to get this working in my house. If you are not comfortable with electrics yourself, please hire a qualified electrician to do this work for you. Electricity can be very dangerous, so yeah, please be careful. Right, with that done, let's get this open and see what we've got. So I just thought of one more thing before we open this up. So I use Home Assistant in my house, so I will, in this video, I'll show you how I install the Shelly, how I get the Shelly integrated within Home Assistant, and I'll also show you my Node-RED setup, or I'll have to work out how to do it obviously, but once I've got the Node-RED setup working so that the switch overrides the motion sensors. So I'll try and include all of that in this video. Yeah, let me know if you have any questions after watching it, but yeah, let's get on with it and see how we get on. Okay, so here is a look inside the switch. I've already tested it using my multimeter down here. Everything is definitely powered off. And we can immediately see that this gang is not being used at all. So that's great. I can hopefully reuse this for something else. It's quite complicated in here, so I'm going to need to go off and try and work out exactly what these different switches are doing. Oh, sorry, how the wires in these switches are working. But from what I can see, It does look like this is the main switch. I think this cable back here is the actual cable out to all of the spotlights. And then we've got a couple of supplies coming in. And then this cable here looks like it's going off to all the other switches in the hallway. So I need to try and work this out. Let me do that and then I'll be back. Good thing is there's lots of space in here to fit a Shelly 2.5. So hopefully this is all possible. Okay, so to try to help explain this, I've drawn a few diagrams. This first diagram shows the wiring as I found it initially. Now, I've simplified this diagram quite significantly. I've removed the earth wires completely from the diagram because they're not really relevant for the way the Shelly's wired up. And I've also only included the 2 switches that will eventually be connected to the Shelly and the 3 cables that are necessary for those 2 switches to work. The other 2 switches I've removed from this diagram completely. So what you can see there is that switch number 1 is completely unused. There are no cables connected to it at all. Switch number 2 is the switch that controls the spotlights in the hallway. You've got the 2 supply cables coming in from the on the top left there. That's the supply coming in and then the supply going out to the rest of the lights in the downstairs of my house. And the live, which is in brown, of the 2 supplies are connected together via that L1 connector on switch number 2. All of the neutrals are connected into a wire block at the back, which was just at the back of the enclosure, and the neutral then also goes off to the actual spotlights themselves. Now, we've also got a 3-core cable, 3-core plus earth cable, that connects the switch number 2 to all the other switches in the hallway. I've got various switches around the hallway, any of which can be used to turn on and off the spotlights. And that is achieved by using that 3-core cable, which then goes through each of the other switches. Now, when you find a 3-core cable like that connecting to other switches, it can make it look very, very complicated and therefore can be quite intimidating to try to work out exactly where the Shelly needs to go. But actually that 3-core cable is not relevant at all for working out where the Shelly needs to go. All you actually need to do is look for the cable that goes off to the lights itself from the switch, i.e. which of the cables is going to be made live when the switch is turned on, that then makes the lights come off, which then makes the lights turn on. And in my case, that is the cable that's connected to L2, that live cable connected to L2 that goes off to the light. Right, that's how it was set up initially. Let's move on to the next diagram. And what I've done is I've broken it down into multiple diagrams to show you how I wired this up. So yeah, let's move on to the next diagram. Right, so this was the first step. So you can see the Shelly up there on the right-hand top right. I haven't connected anything to the Shelly yet at all, but what I have done is the 2 supplies now, instead of connecting via that L1 connector of switch number 2, I've moved those the 2 live connectors coming from the supply into a Wago connector. And then I've taken a cable out of the Wago connector to deliver live to the L1 switch the L1 connector, on switch number 2. I also replaced the old wire block with a Wago connector for the neutrals, and re-established exactly the same cabling that was there in the previous wire block. So that's the first step. The second step was then to wire up the Shelly to the switch number 2. And so to do that, we need to wire the connector that becomes live when the switch is used, which is L2, to the SW1 connector on the Shelly. That then means that when the switch is turned on and off, the Shelly knows that the switch has been turned on and off. So it senses the current coming from the switch and knows that the switch is either in the on or the off position. Then what we do is we connect the load for the lights themselves, so the spotlights themselves, to the 0-1 connector, which is the connector that comes out of the relay within the Shelly itself. Then, to move on to the to wiring up the switch number 1. This was the switch that didn't previously have any cables or any connections to it. What I did there is I took one of the L's, one of the lives from the Shelly, and wired that up to the COM switch on switch number 1, and then I wired up L2, which is the switch, which is the one of the, well, which will become live as the switch is used, up to the SW1 connect, or SW2, sorry, connector on the Shelly itself. Now I didn't wire anything up to the 0 to the load for the second relay because there is no physical light to be turned on and off by the Shelly. Instead, I'm only going to be using the Shelly to sense when the switch is used. And then the final step is you then need to actually provide permanent live and permanent neutral to the Shelly itself. So I did that from those Wago connectors. I took a live from the Wago block, the live Wago connectors, and connected that into the other L connector on the Shelly. And I took a neutral from the Wago connector and wired that up to the neutral connector on the Shelly. And that is it. That's all the wiring in place. Then it was a case of just trying to work out how to fit all of this into the back box behind the switch. I'm very lucky within my house. I've got very deep back boxes, so that wasn't overly difficult. But once that was in, all the wiring was done, and then it was a case of moving on to actually integrating the Shelly into my smart home and getting everything working. Okay, so with everything installed, it was then a case of actually adding the Shelly to the smart home. I started this off via the Shelly app, clicking on the add device and then finding it via a Wi-Fi scan. This is all. The Shelly onboarding process works very well. It's pretty quick. All you have to do is give it your Wi-Fi credentials, then it will search for the Shelly device, find it, join that device's access point, and then set it up with your Wi-Fi credentials so that the device can join the network afterwards. Right, once that's done, you just need to give it a name. I'm not sure how important this is because I think you override all of these settings in Home Assistant, but yeah, you give it a name, assign it to a room if you wish, and then you're ready to move on to the next section. Right, once it's then set up in the app, what you actually need to do is go into the browser and go to the IP address for the device and sign in. Once you're in there, I always just update the firmware initially, so make sure it's on the latest firmware. I've actually had the Shelly for ages, so the firmware was very, very out of date. So that process worked very well. It's pretty smooth to update it. Once it's done, you can then go on with actually configuring the settings to make it work within Home Assistant. Now, for me personally, there's a few settings within Internet and Security that I need to configure. The first of which is the advanced developer settings. I changed the co-IoT peer to the IP address of my Home Assistant server on the correct port. I disable the cloud integration so that the device will only work locally. I actually will eventually prevent these devices from being able to access the internet at all via a firewall setting. And then with that set, I then, just as an additional bit of security, I also changed the username and password on the device just so that there's a non-standard username and password enabled for the device. Right, with that done, it's then a case of setting up the switches correctly. So in my case, I want to detach the switches, i.e. I don't want the switch to actually turn on and off the relay. I want the relay and the switch to be controlled separately. So you can do that within the button type settings. There's a detach switch option. When you do that, it then enables, or it disconnects the switch from the relay so that you can see both of them independently within Home Assistant. So I detached them. I gave the channels a sensible name so that I could work out which one was which. And then that's the settings that's configured within the Shelly themselves, and it's ready to then move on to the Home Assistant configuration. So the first job in Home Assistant is to add the device. I use the Shelly integration, and it's been very reliable for me. So you just go to the Shelly integration, add a new device, enter the IP address, and then enter the username and password that you configured as part of the previous setting within the Shelly's web UI. So once the device is added, you can then go into the device to see all the sensors and controls. And what you'll notice is that the switch position, whether the switch is in the on or off position, does not appear by default. All you can see are the relays and the amount of watts each relay is taking. You can turn the relays on or off within Home Assistant, but you can't see whether the physical position of the switch is in the on or off position. Now, to fix that, you need to expand the sensor section to see the disabled sensors, and then you'll see that the two switches are there. If you click on either one, you can then go into the settings for that switch, and inside those settings there's the option to enable it, and that will also make it visible within Home Assistant. Once that's done, it will then appear within Node-RED, and you can start to build some automations. Just before moving on to the Node-RED setup, I just first wanted to show you that in the developer tools, if you look at the states tab, you can search for the hallway for the Shelly 2.5, which in my case, the actual switch is called the binary sensor hallway spots input. And here you can see, as I flick the switch between the on and the off position, the state of that switch in Home Assistant changing between on and off. Right, now to move on to the Node-RED setup. Right, in this video, I'm going to assume that you have some basic knowledge on Node-RED. There are lots of excellent videos out there if you're not familiar with Node-RED, that will guide you through how to create your first flows or automations within Node-RED. I've been using Home Assistant for about a year, so I'm definitely still new to this and learning along the way. So bear in mind that this is the way that I've implemented this. I'm sure there are many different ways of doing the same thing. Many of those other ways of doing it might be better than this way. So this is just one option. This isn't the only option for implementing this type of logic. Right, okay. With that said, let me first explain what I'm trying to do here. So what I want to happen is that when the switch is used in the hallway, it will override the motion sensors and turn the lights on. But I want the motion sensors to take back over control after a certain amount of time. So I either want the motion sensors to take back over control when somebody flicks the switch off again. So, when they're done with the hallway, the ideal situation is that they turn the lights off and then the motion sensors take on control again. But I also want the motion sensors to take over control again if somebody forgets to turn them off after a certain amount of time. Now, because of that, I can't rely on the actual switch position to be able to determine whether the logic should be on or off, because somebody might turn it on, forget about it, and then that become the new off position. So instead, I need to look for a change in state rather than the actual state of the switch in the hallway, or one of the switches in the hallway. So because I can't rely on the actual position of the switch, I needed, or at least the way I thought about doing this, was to create a variable that I could store whether the override is on or off in, that I could then use within my logic to make sure that the motion sensors didn't then override whatever the switch position was in. So to do that, you go into settings. Hang on, let me just go back out. So you go into settings, then devices and services, and then helpers. And I created this helper called the hallway switch override, which is a toggle helper, which actually is an input_boolean variable. And in there, you'll see if you open it, it's just a simple on-off switch that can be used, that can either be set within Home Assistant itself, as in by clicking on a button, or can be set and the state can be checked within Node-RED. So I created this variable. It's called input_boolean.hallway switch override. Okay, with that set, let me go back into my Node-RED setup. You can see in here, I've created a switch override section. So this section in purple at the top here is the logic that will be, contains the logic for the switch itself. And I've also got this motion sensor section in the green box at the bottom that defines the logic that happens when the motion sensor detects motion. And then in this yellow box on the right here, I've actually got the hallway lights, the various settings for the hallway lights. Okay, let's start off with this purple section at the top, the switch override section. You can see at the beginning here, I've got this event state module. I'm probably going to use the wrong terminology here, but this hallway switch, or this event state module, which is watching the hallway spot input button. So that's or the hallway spot input sensor. So that's the actual switch. So this flow or this automation will be triggered when somebody changes the state of the switch in the hallway. When that is done, the very first thing I do is check that toggle that I just created. Is this input underscore boolean dot hallway switch override in the on or off position? And that's what this switch module does. So if it's in the off position, i.e. it hasn't been used, then it goes up through this top set of logic. And if it's in the on position, then it will go down through this bottom set of logic. So if the switch is off and it goes to on, if the override is off and the switch is used, then the very first thing I do is I set the override to on. And then after that, I turn the lights on to their day setting, which is their brightest setting. If the switch is used, but the override is actually in the off position, then I disable the override. So I turn off the override and I turn the lights off. So that's if the switch is used. If it's flicked on, then the lights come on. If it's flicked off quickly, then the lights are turned off. But also, I want to account for that somebody forgetting scenario. So when the switch is used, but the override is in the off position, in addition to turning the lights on, I also set a trigger that waits 10 minutes. So this trigger will wait for 10 minutes, and then it will disable the override and turn the hallway lights off. So that's the switch override. Now, moving on to the motion sensor, one of the problems with this idea is that you could use the switch, turn the lights on, and then turn the lights on, say, to full brightness, and then the motion sensor detects motion, and let's say it's the middle of the night. Well, it will then follow its automation and turn the lights on to night mode. So I needed to make sure that I could prevent the motion sensor logic from working if the override was in the on position. So that's what I've done here. So in this motion sensor box, you can see I've got two motion sensors. Because the hallway is fairly large, the one motion sensor doesn't cover the whole thing. So I've got one at one end and one at the other. If either of them detect motion, then they go to the on position. So the payload becomes on. And then the very first thing I do is I check if the override is on. So is the override on or off? If it's off, then continue with the flow. If it's on, then die immediately. So that then means that if someone has used the switch, it kills the motion logic at the very first step. Now, the important thing to make sure this still works is at the bottom here, you see I've got this message.payload equals message.payload. So if it does continue the flow, I want to pass through the state from the motion sensor, not the state from the toggle. Right? So if the motion sensor is going from going to an on position, I want that motion sensor state to flow through. If the motion sensor is going to an off position, again, I want that motion sensor state to flow through. So this hallway override check will just pass through whatever the state is from the motion sensor, but will only pass it through if the hallway switch override is in the off position. Okay, then the rest of the flow is pretty standard. So I've got this switch here that will look at the motion sensor state. If the motion sensor state is going to on, then I will check to see how bright it is in the hallway. If the hallway is bright anyway, there's no point in turning the lights on. If the hallway isn't bright enough, then I will check what time of day it is, and based on the time of day, I will turn the lights on to different levels, either full brightness during the day, a warmer light in the evenings, or a night light in the overnight. Going back to the switch, if the motion sensors are going to an off position, then I wait 60 seconds, and then I will check to see if the override has been used, because maybe something's changed in those 60 seconds. And assuming the override is still in the off position, I will turn the lights off. Okay, so that's the flow. Hopefully that all makes sense. If you have any questions about this flow, please do let me know. As I mentioned, there are some excellent videos on how to use Node-RED, so please do go out there and have a look at some of those videos if you're unfamiliar with how Node-RED works. But if you have any questions on my flow in particular, please do let me know. And yeah, let's move on to a quick demo of how this all works in practice. Okay, so if I walk out into the hallway, the motion sensor detects my presence and turns the lights on. It's quite late now, so the lights are on in in the overnight dim state. But if I turn this light switch on, it overrides it and turns the lights on to full, which is great. But if I then walk over to the other side of the hallway, use another one of the switches, it turns the lights off again. So yeah, it's working really, really well. Very happy with the way it's turned out. So anyway, thank you very much for watching. I hope you found this video useful. If you have, please do consider liking and subscribing. There'll be more content coming along very soon. Thanks for watching.